Hey there, class. We're here today to look at vectors and specifically what it means to add a vector. So, real quick review of some things here in physics. We have two kind of quantities that we deal with. We can kind of classify them. The first of which are something called a scalar. Now, a scalar has magnitude only. Now, what you need to remember here when we talk about magnitude, what I'm thinking is simply the size or an amount of something. Okay, so magnitude is just a fancy word we use in physics for that. And then where we're going to really talk about a lot today here is this idea of a vector. So a vector has not only magnitude, but the important thing that makes it different than a scalar is direction. So let's look at the simplest cases possible here first. So let's take two vectors, and let's say our first vector here is, we'll just draw a vector, and again, we're going to say this is, let's say, 2 meters, and that's the magnitude of that vector, but we also need a direction, and that direction we're going to say is to the east. And again, you can imagine something walking 2 meters to the east. You can imagine something driving 2 meters to the east. Something's moved 2 meters to the east from some kind of starting location kind of right here. Then from this point, this thing continues for an additional 4 meters to the east. All right, so again, the second vector. So basically when we add these two vectors together, what we're going to get is really just a simple addition kind of thing here, where we have the 2 meters plus the 4 meters will give us a complete amount of 4 meters east. All right, and when we take and add the two vectors together, I guess I should have given these some names here. Let's call this the vector A, and we'll call this the vector B. When we say the vector A plus the vector B, we say it's equal to another vector. In this case, I like to use R, and R stands for resultant. The resultant is the summation of two or more vectors. So the resultant vector from 2 meters east and 4 meters east is not 4 meters. Why did I put 4 meters there? That should be 6 meters. Hopefully you caught that mistake. That's a pretty simple math. 2 plus 4, of course, gives us 6. So let's take a look at another example. Let's take those similar vectors. Let's take a 2 meter east vector. So this is 2 meters east. We'll call that vector A. And then from this point, we actually go back 4 meters to the west. So 4 meters, this is going to be vector B, and vector B is going to be 4 meters west. All right. Now, hopefully in this case, you can see here, unlike before where it was really just adding one to the other, in effect what's happening here is we are going to, you're going to have to actually kind of, in some respects, subtract. It's almost like walking in a positive direction and a negative direction. And of course, the result in this case, from the very beginning to the very end, if this is where I've started, and this is where I've ended, my resultant vector is this vector right here. And in this case, it's going to be 2 meters to the west. And again, I could think of these as if this were like a math class or something where, we could call this the positive part if this was a number line, and this could be here, this could be the minus on the number line. You can kind of think of it in that terms too. Now the question is, what happens if we're not going west and east, in other words, collinear? Collinear means along the same line. And if it's not north and south, what if it's at some angle here? So let's just take a look at maybe, let's say this is 2 meters, this is the vector A. And let's say it's 2 meters to the northeast. And let's say our second vector is, I don't know, we'll say something like, we'll say 2 meters this way. So vector B is equal to 2 meters. And, something I should mention here real quick is that you still have to think about this being from, think about almost setting a new origin here. When we draw the second vector, that this is still the north direction is still this way. And so this vector here is going to be some vector at some angle, and we'll kind of define how we define directions in another video. But for now, let's just simply say this is something like 20 degrees north of east. So pretty much the same kind of logic applies as we dealt with earlier, where we had starting at the beginning and where you were at the end. We've done that on both of these, where here was the beginning right here and there was the end right here. The same thing applies. Even if they're not collinear, we will in fact do the exact same thing. So as I draw my resultant, I know this is where I started and this is where I've ended. So my vector gets drawn from here to here. And again, this would be my resultant vector. This would be the summation of the vector A plus the vector B, and that's going to give me the vector R, or again, what we call the resultant vector. And again, we'll get into more details later on how to actually do this mathematically. The purpose of this video is really just to introduce the concept to you on how vectors actually combine together.